Thank you. This is loud. Okay, first of all, I want to thank the organizers that invited us here with the winners of NASA Space Up Challenge Orlando to come here and present our experience with this event. As you can see, I kind of, changed the title because at the end, everything that these NASA programs intend to do is to motivate citizen-led open data innovation. And I'm going to go through some resources that they publish from 2012 up until now, and events that you can visit on site and get involved with the community. So, okay, little about me. I finished my Faculty of Computer Science in my hometown, Skopje, Macedonia, if someone knows where Macedonia is. Does someone know? One. Oh, that's great. Currently, I'm finishing my data science master's at UCF, and I've been leading NASA Space Up project for 5 years in Skopje, Silicon Valley, and this year in Orlando. I've been part of NASA Data now since 2017. I'm a Fulbright scholar and obviously space enthusiast. So I wanted to start with this quote, and while you're reading it, just imagine that this quote was published in 2012. Right? Can you imagine the amount of data that they are gathering at this moment from their current active missions? So we all know that the data is increasing, the data volume is increasing, and there are many challenges that NASA is facing even since 2009 when they published their open government plan. And I'm going to go through some of the actions that they did, but also what I want to highlight with this presentation is how you particularly can get involved as a citizen, similar to the way that I got involved with. So they find a way that they can speed up downloading data to 1,000 times faster, but then the question is, can they handle it? They figure out, okay, we have this massive amount of data, and we don't need every part of the data, so we are going to pick only the important part of the data. But again, what does important data mean? And then there are more challenges how to specify and how to make meaningful data. But also this important data is, I know the picture, right? It's still huge, right? So the challenges is not only data volume, but how to index it, where to store it, how to search it, how to transfer it. So all this stuff increases exponentially with data volume. So for example, the climate change data repository size that they currently have is estimated to increase to 230 petabytes by the end of 2030. So in comparison, all letters delivered by US Postal Service in only 1 year is equivalent to 5 petabytes. So what they did was they introduced the Open Government Plan. This was in 2009, but what they lacked in the first version was this part. And then in version 2.0, they said, okay, we will have 2 goals. The first goal is we are going to find opportunities how we can enhance the exploitation of this data that we currently have, but also we want to encourage citizens to utilize these data sets that we have and somehow indirectly contribute to our missions. And I need to highlight here that everything that I share here is my opinion, it's not NASA's. We need to say that. Okay. So first part, online resources. I'm going to go through 4 platforms that they publish as part of the Open Governmental Plan, and then I'm going to go through the NASA Space Up Challenge and NASA Data Notes program. So this was the first open data portal that they published, 2012. You can search through categories, you can view types. I've searched here with Python. There are 18 results, not that many, but again, there are many others. So this is kind of the main one where you can go there and find everything that you need. The more specific ones are Code NASA, and this is basically NASA affiliates and NASA employees' initiative to create open source projects. So basically everyone can use it, but not everyone can contribute to it. You need to be affiliate or employee to NASA. But then again, there are the APIs of NASA. Here you can use them in your app, or you can send an API template and just wait for it to be confirmed and then added to the community. The most specific one that I wanted to share is the Earth data, NASA, and this has been, I think, the most interesting one to be used from our participants at NASA Space Up Challenge. So here you can interactively browse full resolution images, and you can see different categories that you can search from. And then you also have a visualization tool that NASA is providing. So basically you can visualize the data over there, or you can just extract it and exploit it in your own applications. So these are the online resources. They initiated the Open Data Innovator Program. This is basically the second step of their plan to engage the citizens into contributing to this open data citizen-led innovation. So here they are initiating 4 different types of events or programs or mentorship support, and I'm going to cover 2 of those because I've been individually involved in those, and I can share a little bit of my experience with it. But you can see these are the numbers of the data sets and code repositories, and these are the goals that they intend to achieve. There is the government voice. We'll see about that. Okay, so the first one, NASA Data Notes. This is a 1 semester long program. For this program, you don't necessarily need to be a senior software engineer, or you can be a coding newbie. You can be a designer, whatever. If you are just interested in contributing to the open data space, you can join here. So it attracts data newcomers. So how it works, they give you monthly challenges, and then you work with NASA experts. Those monthly challenges depend on your skill level and on your interest. So you're building your own program by working with NASA's data and NASA's employees. If you want, if you're that kind of person, you can also host community events and then engage more people to your cause or whatever you're intending to do here. And the best thing is you can be alumni for life. After 2017, I'm still enjoying the benefits of being there. I work with the newcomers, I work with the new data sets, all sorts of opportunities. The most important part of this Open NASA Innovator Program is the International Space Up Challenge. It's the most important because with this event, they've achieved to engage the biggest number of participants. So this is basically a 48-hour hackathon, and participants address challenges we face on Earth and in space. NASA is making these challenges, and you will see, I have one slide, how those challenges look like. So for this event, you can host, you can participate in it, you can mentor it, or you can sponsor it, similar as PyData. So the thing is, for instance, in Florida, this year, there was only one event in Orlando, and if someone is interested from here, from Miami, to join the community, I will be providing the links at the end, and seriously, if you apply for a license to host the event, it will be, easy to get it. So 2017 in numbers, they published 25 challenges. 2017 solutions were submitted. We had 25,000 participants in 187 cities. For 2018, we still don't have the numbers, but they're bigger than these ones. So in those 5 years, more than 150,000 citizens were engaged. And for a community-led events, that is a really big number. And it's not only the US, it's the whole world. So who is the program for? As I said, people that are enthusiasts, people that want to build their tech skills, build their network, if they want to get active as a citizen, senior engineers, designers, coders, enthusiasts. I've put designers twice, so definitely be a designer. Okay, musician, biologist, entrepreneur. If you're a ninja, you can do everything. So, what's the most interesting part is there is a Space Up Kids version. So it's really interesting to see how they're contributing to the space. Their ideas are really, really good. They're future rocket scientists. So this is one of the challenges that we had last year. Don't forget the can opener. So participants here needed to create their own application to inform their communities of a potential kinds of disaster. And you can see here, this part is also published on the page where the challenge is, and they show you examples of resources that you can particularly use for this application. But again, if you have those links that I've shared you before, the resources, you can just find your own ones, not only these ones that are published here. So for instance, this was one of the applications that are currently competing for finalists on a global level. And they use Area Project for Natural Hazards. It is from NASA JPL Caltech. So it's not listed on those resources, but they exploited this data and their product looks really good. What it's really interesting is that at the end of this event, the ownership of the code is on the team. It's not NASA's, it's not anyone else. So finishing with this slide, I want to invite the Florida winners to share their experience with you for the Space Apps Orlando. So give them applause.
Hey, good morning. I'm David Lockett, and this is Eric Good. We want to talk to you a little bit today about our experience with the Orlando NASA Space Apps Challenge. It was a very rewarding experience, very positive experience. The name of our project was called Weather to Launch. It's got a big meaning behind that, very practical use, can be used kind of across the board. We are 1/3 of this team, so we've got the rest kind of in tow.
They're all still sleeping.
Yes.
So what we wanted to work on, one of the projects you could work on was launches. So launches from NASA, private company launches, and it's something that interests us, not only being from Florida, but being from Orlando. We're about an hour away from the Cape, so I go and try to watch them as much as I can. Something that interests us, though, is when you go and you're sitting there waiting and it doesn't launch and you're sitting there trying to figure out why. That's extremely frustrating. You just wasted your whole day and they delayed because the winds are 20 miles per hour and their max is 15. So it was a waste of time. So we wanted to find out if there's a way that we can sort of predict a little bit of what the weather's going to be like on the day of launch so we can decide if we want to go out there. So that's where Weather to Launch came from. So what we were doing is we were taking APIs from weather websites and we were taking launch data of up and coming launches to find out what the wind speeds were going to be on that day and put it to the criteria of what NASA's criteria are for the different rockets. We wanted to go back in history, but we actually couldn't find, we found history of launches in the past, but a lot of them didn't have data on why they were canceled or why they were delayed. Talking to the NASA rep that we had, she said they usually don't put that information out there. They try not to explain why they didn't launch, which I understand, but it didn't really help us too much. But if we could get that information, we could find a little bit more of what we're just concentrating on weather. We would like to go more into other criteria that could prevent it from going off, but if we could get a little bit more information on what weather caused it to not launch, it would help us understand a little bit more. But again, it's something that we thought would be super useful. You can look at it, it's like going to the beach. You look at the weather, it says 90% chance of rain. You're probably not going to go to the beach. So we wanted to do sort of the same concept with launches. So that was sort of our concept. We do have a website up. It's weathertolaunch.com. There's nothing on there besides like an intro. The data we were collecting, it ran out of money. So we're currently trying to switch it over to Firebase storage, and we're working on doing apps with Flutter, so that way Apple and Android users can use it. But the website's up. It has our link to our NASA apps page, and it has our link to our GitHub, so if you guys want to check out the code on there. But we were going to have, what are those called? Gauges. Mm-hmm. We were going to have gauges that show you the range of danger of what the wind speeds, thunderstorms in a range. One thing we found out, if it lightnings, they have to wait at least 45 minutes before they can even attempt again. So if it lightnings within, I think it was like 15 miles, they have to wait 45 minutes before they can launch again. So that's something where you can see, okay, there's a thunderstorm coming through. I'm not gonna waste my time driving out there. Or you can go and hope it goes off. So those are some of the things that we were looking at. Another one that was really curious to me was launch windows. Sometimes the launch windows can be 4 hours. Sometimes they can be, literally, we saw one, I think it was like 2 minutes. They had a launch window for 2 minutes. So if it's 2 minutes, a high risk that something could go wrong in those 2 minutes, and it's probably not going off. So that was another factor that we took in. And then some of the data we took from NASA was just information about the rockets. If it was a NASA rocket, which right now I don't think they have any, it's Delta and SpaceX and all them, but they had information on the different payloads, on the rockets, on the missions, and we linked all that information on the specific rocket that was going up and what mission was going on. So, and it was going to work with all over the world too. So it takes rockets from all over, not just Florida. So how we did it, we used Firebase, we used Ares weather API, and then we used, there's flight, I think it was Launches Library, launcheslibrary.com or something like that. It has an API on all the up and coming libraries. Oh yeah, there we go. Launch Library, it was close. That library has all the, and it's actually a really good library if you just want to look at what launches are coming up. It gives you the time, gives you all the good information, the window, the mission, all the information is really there that helps you out with that. So those are some of the tools we used. David's going to talk a little more about experience.
So our experience when we came into this, we didn't have any idea what would come out of it. You know, it was a collaborative process. You know, we had some fantastic leaders that guided us through the process. You know, we wanted to think, how could we make it educational? How could we make it available so, you know, it could be beneficial to everyone? I'm an IT teacher, middle school and high school. You know, when I talked to my students about this, they were amazed. They were like, wow, you know, when can we use this? What was the process behind it? I said, lots of pizza and Red Bull. So, you know, definitely a worthwhile experience, you know, something that we took a lot away from. You know, we're working on it now. We're building. You know, we look at the total process and not only what we can learn from it, but, you know, what we can have others learn from it and, you know, make it as educational as possible.
Yeah, it was actually my first hackathon. So, and I was only 6 months into coding, so I still have no clue what I'm doing, but I learned a lot in those 48 hours. So it's a really fun experience. So go and try it out, and you pretty much can go in and do whatever you want. I plan on doing this again next year and hopefully working on this a little bit more. Maybe win again.
Yes. Yes.
Thank you, guys.
Thank you.
Thank you, guys. Keep them in case you have questions. Any questions for any of our speakers?
I may have missed it, but there were 6 on your team. How are you related to each other, connected? Are you coworkers, friends, students, or were you put together?
We met that day.
Yes. That
We literally walked in, and I think two people were talking about launches, and I was like, oh, I like rocket launches, and literally we just all got together and ended up being a team. So it was fun to, meeting David, he taught me about, or he showed me Maker's Fair. He taught me a lot about other things. So it was actually a good community growing.
Yes.
Good networking too.
How much of this time, I guess from your process of injecting the data, how much of it do you need to clean it versus automatically cleanse to import or API into the system?
It was pretty instant. A lot of it was just taken, Garrett, the other guy on our team, he was the one putting it into Firebase, and he was updating it pretty much instantly, and we just took the information we needed. It was pretty basic APIs, so we just got what we needed from it.
Got one over here.
Hi, actually, I have a question about this open data. So for these kinds of like Earth data, they are all connected. Like when you actually publish those data through the website, how do you determine like what's best API, you know, to satisfy the client's needs? How do you organize those connected data? Like, are those weather like Earth data connected naturally, or let's say like it's, I mean,
Or they are what?
connected, I mean related, or something like that?
You're asking about the APIs or?
I'm asking about the API. When you design the API, I'm asking like, how do you design the API of this program?
So the thing is that NASA's programs, they have different parts of that program. And then citizens, you can build your own API and then just upload it there. You don't need to connect that API to something. You can just send your API template to the page. But if you want to use the API that is published there, you can connect it with your application, if that's what you're asking.
Oh, okay. Yeah.
Basically, it's just your work. You need to work through it.
Yeah, so, well, the weather actually, NASA doesn't have a weather API. We had to take it from another website, but we took the weather API and we took the launch library and we created our own API and then pulled all the information from that. So, yeah, so we created our own API and then we took everything from that and put it into our database.
Okay, I have some swags for you.
You should have asked the question.
Well, we've got some free questions. I don't think there's swag that goes with it, but.
And you can't ask, can I get a bag?
Yeah, when you had those risk scores, the meters or whatever, was that something that you just kind of hard-coded criteria for, or did you fit a model predicting cancellation risk? And
no, our original plan was we wanted to do machine learning and take past history and put in the criteria and have it give us a gauge by itself, but we couldn't find the data in the past of why they were canceled. So we just took the criteria of what NASA says is for the rocket, or whoever is the criteria for the rocket, and then what the conditions are going to be that day, and then we just made a percentage out of it.
Anyone else? No.
Thanks. So, quick question. You guys did really well. You guys won. But you guys said you guys were missing a lot of the previous data. Now, is NASA thinking about giving them that information? Or is that not a thing?
You want to answer that?
Okay, thanks for asking that question. So, in particular for this team and for other teams that are part of this program, we tend to collect this information from their experience and kind of send that to those people at NASA who kind of make the decisions for these kinds of stuff. But definitely, yeah, we really want to hear the feedback. And when I say we, I am as a community leader here. But then there are other structures that decide on, these questions. So definitely, we're here to listen. And again, I guess they need the forecasts, right, for the applications. We'll see about that.
The NASA rep that was there, she was actually really interested in the idea, and she's actually one of the lead people that determines if it does go or not. So we asked her personally, like, how do you guys determine it? And she said it's literally somebody just looking at the weather and saying, yeah, I guess we should go. So she liked the idea of having something, maybe give them an idea of how it's going to be. So she gave us some links to get some more information on weather, but they said they won't release why they won't launch a rocket. So we wanted to actually start collecting rockets that weren't launched and compare the weather to that day so we can have an idea of what's going and what's not going during weathers, but they won't tell us why they won't launch it. It could be, she said they can launch because somebody didn't show up that day. I mean, she literally said there could be somebody that important that didn't show up and didn't launch, but they won't tell us.
And it also depends on the contracts. SpaceX is now launching from there, other companies are. So it really depends, yeah.
So did you apply this algorithm to previous launches, and did you see it giving you accurate results?
Yeah, we had a launch, I think it was the day after we finished ours, and it was pretty accurate as far as, the thing is, it was actually the picture we had up there, it was a launch from like an airplane. They drop a rocket and shoot off there. So that one's hard to track because you don't have a specific location of where it's being launched. It's wherever the plane is. But there was recently a launch, I think like a month ago, and they delayed it 3 times because the winds were above the threshold, and the data we were looking at, it said it was in the red. It said it's highly unlikely it wasn't going to go. So it is practical. It does work. We just need to get a better weather API. The best we can get is 14 days forward, so we can only really predict 14 days before the launch.
Oh, so your your model would be accurate if somebody looked for it like within a couple of weeks before the launch.
Yes, yeah, and that's why we wanted past data so we can do it that way, but we can't get that information.
Thanks.
This is weather data you're using, right?
Yeah.
How extendable is it to, say, hurricane prediction? Can you say,
Extendable?
because you are looking at weather 14 days ahead.
Well, we're just using the weather API. It just gives us the forecast for 14 days. So if there's a hurricane in 14 days, it's probably not going.
And we got one more.
I guess on the topic of NASA using it, there's also the feedback loop of if I'm the person making the go, no code call at NASA, and I know that a lot of people have gone to the site and are expecting a yes launch or expecting a no launch, is that going to factor into my decision what to do based on all those fans out there?
I hope they say go because I drove out there. But I mean, hopefully they're not. I don't think they're going to be using ours to make the decision. This was more for, I just was super interested because I've gone out there plenty of times and they cancel it, and that's just really frustrating. But it'd be really cool if they would use it.
All right, well, thanks again.